From I Am Interchange, this is the Hatch podcast series. At the 2024 G20 Summit, the group of 20 heads of state and international governments that meet annually to address issues relating to global governance and economics. In Rio de Janeiro, Brazil, X Prize Rainforest announced Team Limelight as the grand prize winner of its $10 million incentive competition to better define and understand the intricate rainforest ecosystem. Team Limelight's project utilized drone-deployed multi-taxa monitoring sensors to survey 100 hectares of the rainforest within 24 hours and provide insights regarding those findings within a mere 48, exponentially increasing the advanced biodiversity monitoring possibilities across diverse landscapes and regions worldwide. With more than half of the planet's rainforests destroyed and approximately 20% of the Amazon lost, this innovative development, in addition to the handful more inspired and incentivized by the global 5-year competition, fosters much-needed hope, and none too soon. The innovations developed through X Prize Rainforest will revolutionize how we work together to protect the planet's most diverse and complex ecosystems in a time that has never been more urgent for life on Earth, says X Prize Executive Vice President of Biodiversity and Conservation, Peter Houlihan.
I'm Tate Chamberlain, and in this second installment of a 2-part special Rio G20 series, I interview Team Limelight Rainforest Dr. Thomas Walla, Professor of Biology at Colorado Mesa University, and Outreach Robotics co-founder Guillaume Charon, two among the many creative minds intent on tackling the world's most pressing concerns in X Prize competitions around the globe. Here, they break through the Amazon's canopy to shed light on the world's most misunderstood treasure and all the sway it holds over the future of literally everything.
Welcome, everybody, to the Hatch Podcast. We're in Rio de Janeiro, Brazil for the G20 Summit and the Rainforest X Prize at CASA G20. I'm Tate Chamberlain, and I'm with Thomas Walla and Guillaume Charon with Limelight Rainforest, who won the competition. Welcome, you two. Congratulations, and thanks for being here.
Thank you. It's really a pleasure to be here, Tate.
Yeah, hi, everyone.
What is your first memory of the rainforest?
I think my first memory of the rainforest was a short walk on a trail called Chawamongo Iho. And the trail was named after a local indigenous man named Chawamongo, his son. So it was called Iho de Chawamongo. And that walk was about 20 minutes long. And on that walk, I saw the largest snake of my entire life. It emerged from the leaf litter. It was over 9 feet long and 4 inches in diameter. It traveled like a submarine across the forest floor in front of, I was with a group of tourists. And I was completely terrified. I was like, wow, I mean, I love snakes, but that thing is just appeared and then it went out of view and I followed it and it was gone. I couldn't find it again. And every time I walked that trail for the next 3 years, when I lived in the forest after that, getting tours, I looked for that snake, and I never saw it again. And that, for me, was the tropical rainforest. That's what I learned, is that one day you see something incredibly amazing, and then it's vanished, and you never see it in the same place again. The forest delivers things, and then they disappear.
I don't think I can add on that.
I don't think...
What's your first memory of the rainforest?
It was actually in Brazil a few months ago because we were a bunch of very motivated engineers from Canada and just decided to try to use what we've learned at school and in different projects we did and leverage that to help having an impact. But not in Canada, not in Quebec, not near Montreal. We did that to have an impact in these areas that actually I don't understand well at all. And that's, I think, the most challenging thing was to design for something that you don't really know and to rely on everyone, what they're telling us to do and say, you'll see, it'll work like that in the tropical forests. And actually, we get to test all we developed a few months before the competition and crossed our fingers like, okay, everyone told us tropical rainforest is just like that. Will it happen to be like that and work well with what we've developed? Turns out that I think yes, but still it was so much learning for us through these last months of just living with people that loves rainforest and thrives for it. And I think that's my first experience in the rainforest. It was in Brazil a few months ago. So I'm still discovering a lot from it. And I'm still amazed of all the things you can experience in those areas that a lot of people don't know, actually, just like me before.
Yeah, well, you guys did fantastic. When you arrived, they were like a machine. Outreach Robotics, like their team brought out all this equipment, and it's amazing to sit and imagine there are a lot of parts to a drone until you walk into somebody's tiny little room at a research station and is completely covered wires and batteries and screwdrivers and screws and pieces and parts. And I'm like, oh my God, how are they ever going to put this back together and make it fly? But you did. It was hot and sweaty.
It was hot and, well, actually, we decided to make a rule right before that trial week not to talk about the heat. It was a rule. We cannot complain at all. If someone complains, then he pays the beer, because we need to get to a mindset this is going to be it. We're going to sweat and it'll be hard. And it was hard. But we had the right mindset, and I think that was useful.
It'll be the coldest summer of the rest of your life.
Oh, yeah. I love snow in Quebec.
Yeah, it was. I wish I had thought about not talking about the heat, because I was hot a lot and I complained. I was like, wow, Brazil is even hotter than Ecuador. Yeah. I was very impressed with the heat, and it made things tough. But yeah, you guys did really well out there. I was impressed. We did find out some things cooked in the heat, right?
Yeah.
We fried a whole bunch of, I think we fried 4 different CPUs during our practice run. So temperatures got really hot. We had one that had a temperature monitor on it, and it actually was over 100 degrees Celsius inside the computer, which was bad.
What's the relationship between rainforests and the world?
It's a great question, because it does ask us, what is the rainforest to the consciousness of the world? Where does it fit? And I think there's a lot of answers to that, and none of them are as good as they should be. That relationship it exists as a space in our minds of the ultimate wilderness frontier. So that's the first thing that I think about. If you think about space, people talk about black holes. They talk about the unknown of space. They talk about universes we can't see. And yet, I think in sort of the human consciousness, the rainforest is that space for us on Earth. It is that place where diversity is beyond definition. The species are not even described as science. You could be lost in a moment if you stepped off of the trail, and there is no end to that rainforest. You would start walking. If you got lost in the Amazon in Brazil, you could start walking and you would die of starvation before you found a settlement or people or a road. It is so enormous. And I think that is the sort of space that rainforests holds. I think I might add hope to that, because I think of it as a green fountain of hope for biology, for ecology, for pharmacology. We think about potential drugs coming from the rainforest. There's a hope, I think, that the rainforest can provide salvation for humanity that we don't know how yet. So I do think it is about wilderness, and it's about hope.
We were here to celebrate the Rainforest X Prize, and the prize is technology-based. In what ways does Limelight's technology belong in the rainforest?
I would say that our technology belongs as the primary record keeper. We are the spies of the rainforest. If all that life passes through generation after generation without being witnessed or seen by humans, what our technology can do is actually record and witness the presence and the movements of those species in ways that have never been done before.
Take me through the process of collecting data, start to finish. When you get on the ground and utilize the technology in the drones, what does that look like when you're collecting it?
I think Guillaume should start with the drone component, and I can finish up with some of the part that is the data collection part, because everything has to be delivered by drone to begin with as part of the X Prize.
Yeah, well, the X Prize gave us guidelines. And one of these guidelines was to make a scalable solution, to force the team to do scalable solution. Their main rule was that no one can enter that square kilometer forest by foot. So you need to send monitoring solutions and bring it back. And the best way to do that, and if you just look at a rainforest, trying to figure out a way to navigate under the tree with robots, I mean, that's a big challenge in terms of technology and risks also to just like navigate through that forest. So the best ways was to use drones and literally fly to the targets. So by having drones, we were able to cover that square kilometer area and deliver stuff. But then you have another boundary, which is the canopy, and it's pretty tight out there. Like you don't see the ground at all from above. So I think we had that gave us opportunity actually, because it's just like a grass field you see from above, and it's so dense and so tight that you can use that as a new ground, and then drop stuff on top of the canopy. And that was the mindset we had by developing those technology, and mostly the Limelight raft that we drop on top of the forest. So imagine it's like a video game basically. Imagine a drone, you pilot, you drop a raft on top of a tree, then you leave it there for several days. I guess in the future we'd like to leave it there for months, recording stuff, and then you go pick it back. So that's the way I think we used, and that worked. So the drone is a big component in that, to be able to reach out those areas. And then the other big component is what's the data you want to collect and which sensors you want to drop. And there's a lot of challenges to collecting data, because there's a lot of data that are heavy to store on long durations, like photos, like videos. That's a challenge still, I think.
Like collecting the amount of data in one flight per the amount it's able to capture.
Yeah, well, it's also a lot of power consumption. Like some sensor needs a lot of power to be able to function, and others are very less consumption wise. So that's still a big challenge. Let's say you want to just use acoustic, then it's a little bit easier to think about dropping something for a long period of time. But if you want to take pictures and videos, then it becomes more and more of a challenge to do that. So,
is the floor of the rainforest or the canopy less explored?
Oh, I definitely think the canopy is the great frontier. The great frontier is the canopy, right? So the understory is, I wouldn't say well explored, but the limitation has always been that it's not easy to get into the canopy. That's always been the struggle. Yeah.
What did it look like before this project? What did data collection look like in the rainforest?
So, there's a lot of different people doing a lot of different kinds of amazing ecology out there, but most of them are recording their data pretty much on laptop computers and by hand. You're counting individual species by collecting them. A collected insect, for example, is preserved in the field. It has to be dried and protected from moisture and fungus. It's then, typically we don't prepare those specimens, like butterflies and moths, for example, have to be mounted, their wings spread and dried open to see them. But what we'll do in the tropics is typically fold those into envelopes. We would then carry them back either in if they're butterflies and moths, they would be dried or frozen, freeze-dried basically, or if they're regular insects that are like beetles, they would be in alcohol, and they would be transported back to a museum. So you would need to get export permits, take them out of the country, make some agreements with local museums about returning those specimens for scientific study. Then they would be prepared by specialists in labs in the U.S. or in other countries. And then they're divided into different groups, and specialists around the world would receive the groups that they work on, and they would then identify those taxa. So if you just wanted to do taxonomic identification, that's the typical process. And it takes months, many months. So getting the permits takes months. Getting going down with a suitcase full of insects and bringing them back takes time. And all of this and shipping them out takes time. And then taxonomists are very busy. It's not a well-supported career right now. Taxonomy is a historically glorious position, but we don't have enough taxonomists. So we haven't named all the species in the rainforest because it takes time. Before you can decide that a species gets a new name, you have to know everything, every other species in that group. Like if it's a genus, right? You have to know really well that it has not been described before. And then you have to know how to describe that. It takes a lot of time and a lot of work. And those positions are always overworked because it takes a lot more work than people suspect to do that job. And we don't have enough people doing it. So we're hoping through this to be able to support taxonomists. That's one of our hopes through this process, is that the technology that we use will be different because we can image and identify things very quickly. So what's amazing about what we're doing now, let's say, for example, I did my PhD on fruit-feeding nymphalid butterflies, where they were attracted to baits in a trap, basically, a net trap. And on average, we caught one butterfly per trap per day. And with 50 traps, that, over 5 years, we were close to 10,000 butterflies. In a single night, we imaged 50,000 insects in one Limelight raft. Now, we can't identify all those perfectly, but the computer can very quickly put them into families. And then we've been training it to do genera. And so you can estimate the biomass, you can estimate the number of individuals, you can get a really good idea about diversity, and you can get this in a number of hours after retrieving your trap. This is a completely different scale of data collection than we would traditionally do when studying insect diversity.
And to clarify, it's not that you're putting them all in a suitcase. It's just doing the images and using AI and computers to identify it. And
Yeah. So this is beautiful. What I really like, and we have different aspects to our solution, and there are about 12 independent data streams that make up the data that we're able to collect. One of those data streams is it's basically a camera trap for insects, takes pictures of them. And what's beautiful about it is non-invasive, right? We don't kill anything. Even insects, which people are typically okay with collecting insects, this process doesn't involve that at all. And so the idea is we could be able to do a lot of this monitoring without having to collect eventually. We've complemented that with some collecting tools as well. So we have some Limelight traps that are specially designed for flight intercept traps, like pitfall traps and malaise traps, to capture insects in the traditional way, which would be to preserve them in alcohol, and then we can sequence their DNA, or we can preserve them, mount them, take them to a museum and do that as well. And that process will take more time, and that does build the foundation of knowledge. We need that. But our hope is eventually to go to just photographs, which is not only faster, it's less invasive, and it is all around an amazing new way to examine ecosystems.
Peter was talking about in the history, it's taken months to collect 500 DNA samples. And he said that in your 24 hours, you collected 27 million.
We had 27 million reads. So what that means is we had 27 million bases of DNA sequenced.
So they're not all different. They could be the same.
So, right. Many of that doesn't mean 27 million species. It means 27 million pieces of DNA, which is a lot of, the average DNA barcode is a little over 100 bases long. So if you've sequenced 1,000 of them from one species, then you would have a lot of those copies in there.
If AI takes and aggregates information that already exists, how does it know that it's a new species?
Yeah, this is the problem with the AI, is you have to train those models. Mm-hmm. So it can only do what has been taught. And to teach it, you have to also know those species, right? So you have to feed it. And the AI doesn't work right now on the sequencing. We don't use it for DNA sequencing. It's still, once you have a unique base pair code for a particular insect. So the way the barcoding works is there's, millions and millions of bases in any organism's DNA. ATCG, it goes on through there. And this is a region of DNA that is highly variable among species within genera, typically. So it's about 100 or so bases long, and it's a unique, we call it a barcode because that 100 letters is unique, pretty much unique for every species on Earth. There's so many combinations, right, of those things. And it's most of it is free to vary, so it can be very different among different groups. So if you get a new sequence there at that location, you're pretty sure you have a new DNA species. Like I say DNA species because we have a new piece of DNA. It might be from a species that has been described but hasn't been sequenced, or it might be from a species that has neither been described or sequenced. So we have a lot of unknowns.
Did that happen? Do you have a lot of unknowns?
Yeah, we have a lot of DNA that we don't know what it goes to.
Does it just show up as a question mark?
Well, you can infer that it belongs to a family sometimes. So you can sometimes infer if someone has sequenced something closely related, then that barcode is going to be very similar. So if it's only off by a few bases, you're like, oh, it's probably related to that thing we already have that's in this genus. And then we can say we found a different sequence of DNA in that genus. But the rules of the X Prize and tradition doesn't really allow us to say that's a new species right now. We can't describe a species just from this weird piece of DNA. You need more information. So you would need a specimen to tie that to so that you could verify that that piece of DNA came from that specimen and that specimen is a new species.
And if you found it, do you get to name it?
No, well, actually, in other projects, we built a drone able to sample plants on cliffs, and we've been a lot of time in Hawaii and sampling plants on cliff. And one of that plant we bring back, it was a totally new flower botanists have never seen before. So we asked them, "Are you going to call that new plant against the mamba, the drone that went to collect it?" But we didn't get to choose that name, unfortunately. I wish it was, but no. It's a long process to identify a new species and name it, and it took almost 2 years for that plant to be for sure a new species, and it took multiple collections of it from different stages, and that's for plants. So I guess for species, they don't want to. They need to be very certain that it's a new one before just saying, "Hey, it's a new species." It's not it's a big deal. So I guess it's also a long process.
Yeah, the tradition in entomology is that the person who describes the species gets to choose what to name it, and so they might name it based on a feature of that organism. If it has a long nose, it might get named the Latin name for long nose or something, right?
Sure.
So, and that might make it that would be a proper way to name it. Sometimes they name them after people.
Why is collecting this much data important to saving the rainforest?
The X Prize rainforest competition is based on the idea that if we could develop a gold standard of biodiversity measurement, that we could actually evaluate, like real estate appraisal, more or less, of rainforest, then people could invest in intact rainforest. Like the global economy could invest in it. You could buy a stock fund that might invest in intact rainforest. Currently, rainforest is valued at mostly agricultural prices. So the price of a piece of rainforest right now is about the same as the cow that grows on the grass that grows where the rainforest once stood.
And the trees that were logged to clear it.
In Ecuador, it's actually more expensive to buy cleared rainforest than it is to buy rainforest with trees on it. Because if you buy it with the trees, it takes a bunch of work to get rid of those so you can get down to some agriculture. So the idea is that agriculture does a great job of evaluating what land is worth for potentially growing palm plantations, for example.
If it's ready.
if it's ready, and they also know what it costs to get it ready, right? They know all this business of how to convert rainforest into productive agricultural land, and the prices of that land are based on that. But the world actually does value rainforest. They just don't have a way of realizing that through investments because the scientists are unable to measure biodiversity and measure the value of what's on that place. And that's really what we're striving to do, is collect enough data that we could get a pretty good estimate of what its contribution to our global consciousness, our global value system really is. And if we could do that, then you could invest in rainforest that's standing there, and it would be intact rainforest that you could purchase and hold like a stock. And that would include, of course, the people who live there would receive benefits from that, because the people living in the forest are a dynamic part of that ecosystem as well.
Part of your prize was a $5 million pot. What does scaling Limelight look like with that?
It's a tough question because scaling is expensive. And the $5 million pot is fantastic. Like, we are so thrilled to have that support. But honestly, most of that money was already spent getting here. We spent over $2.5 million just to develop our solution. So much of that has already been spent in a lot of ways. And the scaling, we all have some of that we'll put towards scaling and looking for new ways to deliver these things at a lower cost and deliver them in large numbers. So one of the great ideas that we have is to put the rafts, by multiplying the rafts, say we can fly 50 rafts in a day and deliver those, and then each day move them to new locations. And by moving them to new locations, we can randomize the way in which we're collecting the data, which could really improve its value for some of these organizations that are creating the financial system for nature credits. We also have an on-the-ground system we're looking at developing where somebody might not have to use it with a drone, which is more common right now. And for some projects that are easy to reach on foot, those may be more appropriate. But we're probably always going to complement those with the canopy systems because the canopy is going to be different.
Oh, so the rafts can be used kind of anywhere. You just use drones to reach the canopy because
Yes.
It's been the hardest to reach so far.
Exactly.
But the technology can be used anywhere.
Yeah, you could take the raft, you could take the what we call the skirt off of the raft, and you could hang it in the understory, and it would also collect data.
It was a 5-year process to get up to this point. How did you create the team around you?
That's a long story, I think, Thomas.
Well, I'll tell you the basics of how it worked is that I don't know. I was contacted by a colleague who suggested I should start this, and most of the other faculty that I had met were busy with other projects, and I didn't have a major project I was working on, and I was like, okay, I'll give it a shot. And there was a time when I made that conscientious decision because it's hard to pick up the phone and call. I just picked up the phone and started calling people. I guess that's sort of old-fashioned. I can Zoom them now, though, but I quite literally picked up the phone and said, does anybody know anybody that can do this, that can do that? And so I got references from people. It's building a network, calling them up and saying, hi, my name is Tom. I'm trying to save the rainforest. And if they haven't hung up in the first 3 minutes, that's really good. And then you can tell almost immediately when a person is just, this captures their imagination of what they would like to do with their skills. And you meet these people. One of my favorite people, Garth, who's down at Arizona State University, is really into sound. And when I first met Garth, I was like, this guy's fantastic. And he was just so excited in all the ways that he could use sound of the rainforest to communicate and share with people, because he's an artist that uses sound to evoke emotion and experience in humans. And when you meet each of these people, they're like, yeah, I'm in. And then some other people, not so much. You know, I've called a number of people that are just like, no, we don't do that sort of thing. And you just pass them right up. But you're really sort of it's like dragging a treble hook around the world looking for people that just grab on. And when I first met Guillaume, that was fantastic. We had a series of failures. I had crashed almost $10,000 worth of drones. Trying to train myself to be a drone pilot because I couldn't find any drone pilots that would take me seriously. They were like, rainforests? No way, man.
Actually, that's a good story, I think, because in the first year of the X Prize Rainforest, there was this webinar where companies could showcase their skills to a lot of other teams and say, hey, we're available. Do you want to have some help to develop what you wanted your solution? And we went to that webinar with our company, which is called Outreach Robotics, and nobody answered us. And we said, all right, maybe everyone has already a robotic team building their drone and all their hardware. And 6 months before the semifinal, I got this email from Thomas and say, hey, we're in trouble.
After you wreck the drone?
Yeah. And we got this call. And I remember in this call, say, okay, we're trying to kind of hug the tree trunk with a robotic device and trying to attach those sensors to the trunk of palm trees. And I was like, man, that's a hard thing to do. Like, are you serious? And in the same meeting, I said, all right, Tom, we could be in, but we'll try to do something a little bit more simple and less risky. And we'll just try to drop things on top of the trees. What do you think about that? And I say, let me think about this, because it changes a lot of things for us. And then I got an email maybe like 2 days after and say, hey, Guillaume, you know what? That's a good idea. Do you want to be in? And say, all right, we're in. So 6 months before the final, we started developing the canopy raft, and then it went on to the final, and a lot of fun developments.
So the raft gets dropped off and then picked up, or?
Yeah, exactly. Well, during the X Prize, you cannot leave stuff in the forest. You need to bring back everything you drop there. So otherwise you lose points. So we had to figure out a way to drop them, but also to retrieve them the next day, which is as hard as dropping them. So yeah, that was a lot of brainstorming, thinking, but on my point of view, that's the most fun thing, is to try to think about, you have like a whiteboard and you can do whatever you want. So that was the fun part.
The tree hugger was a great idea. I'm just going to say that.
I haven't seen any other team try that, by the way.
What's the tree hugger?
The tree hugger was the initial, my plan. It was a good plan. I was like, I know something about tropical rainforests. And I guess what I sort of like about this whole story is this is what I learned about design that I didn't know when I began, is that you fall in love with ideas. And then someone like Guillaume comes along and just changes them. Mm. And I'm like, I love that idea. But Guillaume really knows what he's talking about. And he will solve this. And he did. So I had to give it up. My tree hugger was a hook. So I know that the most common species of tree in the tropical rainforest of the Amazon is Iriartea deltoidea, which is a palm tree. Runs about 120 feet tall, no branches. It's a telephone pole. I'm like, we're going to use these telephone poles and we're going to fly down. We're going to hang our device on there. It was like a hook. So it was going to be a hook that hooks around the back of the tree. And then I bought these little robotic arms that extend and contract. And these little extending contractors, which are typically used to open and close doors, right? I had those hooked up, and I had already paid a few $1,000s to have this thing built, and it was a 12-foot long hook that I was going to fly in with a drone and then hook this tree, and then the little arm would come out and stabilize it. And then from there, we were going to lower on a winch up and down all of our collection equipment. It was going to be fantastic.
There was also like an insect treadmill also. This idea of having a treadmill in front of a camera, so you just picture different insects. And I was like, not sure about that. And basically, a lot of time, the hardest thing is to find the most simple solution that will work. That's the hardest part. But once you have it, and I saw other teams that arrived with the X Prize and like with very simple solution, but that worked well. And I was like, wow, I'm amazed from those other teams that found those very simple solutions that work, because it's very easy to go with complexity. Mm-hmm. that will probably fail in the end. So I think that most of the challenge was getting it straight, simple, and working. Because there's so much other stuff that could happen outside what you think could happen into a rainforest, that if your solution is a little bit too complex, then it will fail.
Yeah, and maintaining that complexity.
Yeah.
Who's resisting you? In activism, there typically is a resistance to it.
Yeah, it's an interesting question. I think that when I think about this, I think like, well, really, it isn't really a person or a group. I hate to use the term this way. The term is ignorance, in the true sense that we just don't know enough about tropical rainforests. And that seems to be the problem. Even the large organizations that are very interested in measuring their biodiversity aren't really excited about paying a lot of money to do it. They seem to think there might be this cheap and easy solution out there to figuring out what's in a rainforest. And I don't think it's going to be that cheap or that easy. And part of, I think, what our task is to overcome that lack of knowledge to help the world understand the value of good data from the rainforest, how useful that could be. And I fundamentally think that our goal is to provide something that the world really needs to have, wants to have, and would be willing to pay for it because it will help them make better decisions. It'll help their supply chains be more resilient. It will help them be better citizens of the world, in the world they want to live in. And if we can give them that information, then it has enough value that there will be a market for it. And I think we're not thinking that that's going to be insanely expensive, but it isn't easy.
I might add, since we're in hardware development, I might add also there's a resistance to changes in ways to do things, and the traditional ways to always do the same thing. It has always worked like that, and sometimes it's hard to just change the way you do stuff. So there's a lot of misconceptions also about drones right now and the way we can use them, and people have a hard stop on using those because it seems complex. It seems something that is not in their reach. But actually, drones now are super easy to use, to deploy. In 10 years, there has been so much development that now we can envisage to use them widely. So those misconceptions, I think, is stopping a lot of development in using new technology in the field.
Is the resistance 100% wrong? You had an interesting answer, so I'm not sure what yours would be, like the lack of knowledge around it and seeing the value in it. But in that, even in yours, Guillaume, is it 100% wrong to resist?
I don't know. I think that people are reasonable. I mean, what's interesting is the economics of the world is very reasonable. There's some people out there who want to grow palm plantations on rainforest. I see them as the enemy. Now, that's a resistance. I don't see them as being nonsensical. They make perfect sense. They want to make money growing agricultural products. Their focus is not rainforest biodiversity because they don't see that as a value. And I can understand and respect somebody that wants to make an income on agriculture. That is how humans have gotten where we are today. Agriculture, right? I would like to be able to place something else of value in front of them so they have another choice. Because I just don't feel like they have the choices right now because the market doesn't exist. If they had a market, I feel like they might invest in the other market. They might invest in intact rainforests because they aren't here to do evil. They're here to help humanity progress in as many ways as those of us that are trying to conserve rainforest view that area as ways that humanity can grow and improve. It's just a different emphasis of the value system. And so I don't think that the resistance is wrong. They just need more options.
In the face of losing all this biodiversity and the urgency of it, how far should activism go?
I think activism plays a very important role in that it can help people think differently about systems. And I'm going to reflect on what Guillaume said a moment ago about unwillingness to have change. The introduction of ESG funds to the marketplace, I think, has been a very valuable change. And a lot of people, including, I received some investment advice, and I was looking at my retirement portfolio, and he looked at me and he said, "Tom, you're investing for your retirement here. Are you going to invest in someone's trees and rainforest, or are you going to try to make some money for your retirement?" And I said, "Buy the damn trees." Of course, I'm not desperate for every penny, so my value system is invest in a fund that's environmental, social, and governmentally in line with my ethics. And I like that. But that kind of change, like the activism that occurs in the financial markets, I think isn't really banging a drum on the street, but it's the kind of activism that we need to change the way people think about how they spend money and what is of value to them. That, I think, is a really, really promising way to look at rainforest conservation.
As a future ancestor, what message would you leave for future generations regarding the rainforest?
For my part, I think being a French Canadian living very far from the rainforest and being here right now speaking to you, I think no matter like where you are, you can have an impact if you do the right thing. So I would say that like for future generations, even if you're studying in engineering and 99% of the job is trying to do a robotic supply chain for Amazon. And no, you can decide to do your own project and develop your own idea and go towards where you can have an impact, such as the rainforest or such as a lot of other topics. So I would mostly give them a message to use their own skills in their own manners to have an impact. And it does not always mean to get out in the street and bang on drums, but maybe just use their brain and their own skills to try to save what they think has value for them.
That's a great way of looking at it, because I think the way in which our ability to act globally from a local position has really shifted, it seems to me. So people can really make large impacts starting at home. And I've been amazed by that. I work in my backyard every day. That's how I teach. I teach people. I like that. And that's my impact. But this has been a different kind of impact. And that impact has been really powerful, it feels like. And it's growing, and it's going to get better. And so there'll be more. I'd like, future generations to look back at this one and say, we tried. Today there was a march in front of our hotel, and I think it was very effective. I looked down, and there was a giant banner, and it said, in Portuguese, it said, "We are the last generation who can save the Amazon." And I think that's true. I think hopefully they will look back on this generation and say, yeah, they managed to get it together and save some rainforests around the world, because if they hadn't done it then, we would not have a chance now.
What brings you hope?
I think the whole X Prize challenge has brought me more hope for humanity than I ever imagined was out there. Through this process, I have met the most amazing people. I would never have known Guillaume. I would have never picked up the phone and said, "I need to meet a drone guy from Canada." Never. And yet these guys are committed, and they're committed to positive change. They don't just take any job. They want to do interesting work that has a benefit in society. And I have met so many people like that. And I was at X Prize Visioneering in Malibu, California a few weeks ago, and the entire place was filled with people who lead change every day, entrepreneurs and people doing interesting work and looking for other interesting people and really trying to change the world for the better in sensible, I would call them sensible ways, because these people are successful at making incomes and having positive change. And I think it's really fantastic when those things can be aligned. I think there's a lot more out of there. So I don't know, I'm gonna throw X Prize out there for that one. I'm a real fan. I believe.
What's also bringing hope is how much we can do with so little. X Prize is putting millions of dollars out there to try to leverage people to work towards a goal. But still, if you could look at the big picture on how money is invested anywhere else. It's a fraction of a lot of different investments, and still we did a lot of things with that little fraction. So let's say if investments in the future would go more towards those kind of objectives, then there's a lot that can be done very fast. So that's giving me hope in the future, because I think it's a lot of thing we've done with so little, I would say.
Yeah, I would agree. I think that's a fantastic way of looking at it.
Are there any questions that aren't being asked?
Well, I think for me, I don't know, I just have one big giant question that's been sitting on my mind for 30 years for rainforest ecology. And I think that question is, what is the true spatial and temporal variation in a tropical rainforest across all those species and all that space? I'd really like to know what that is. And we're going to try to find out. So I think with these new tools and the backing of some of the interested people from XPRIZE and other organizations, I think we have a chance of doing that, which is like, it's really like quantifying the noise of a rainforest into its true essence over space and time. And that's going to be great. You know, some of the questions that aren't being asked, you know, is right now we're looking for who will be the clients who will pay for this biodiversity surveys that we can now do. Who really will be the interested people in knowing what's in a tropical rainforest? Now that we have a good chance at knowing it, like who wants that answer? And I think we don't actually know who those people are yet. I think some of them we know, but my hope is that there will be others that come forward as they begin to realize the potential for what we can do with our systems. They will creatively imagine the application of that knowledge.
I'm Tate Chamberlain. This is the Hatch Podcast. Thomas, Guillaume, thanks so much for being here.
It was my pleasure.
Thank you, Tate. This was great.
Contrary to Joseph Conrad's epic, Heart of Darkness, the Amazon, it seems, is more accurately the heart of humanity's hope than its horror. And considering the current menagerie of existential menaces, we could do with a bit more of that. The vast biodiversity of which we've barely scratched the surface in terms of identification and understanding, holds solutions to complex climate, ecosystem, and health-related problems plaguing diverse populations around the globe. Limelight aims to chip away at that ignorance, both taxonomically and socially, slowly uncovering the secrets of the rainforest for its protection and our own. As Walla puts it, we just don't know enough about tropical rainforests, and that seems to be the problem. The resistance in this realm isn't so simply defined by an evil corporation or a corrupt political system. Though they do their fair share of damage, the resistance is complacency. It's seeing the rainforest as something over there, an impossibly out-of-reach locale on the other side of the world. No matter where you live, that's important because we've heard it was important since our elementary days. But that importance has yet to adequately be defined or understood. So we do with the rainforest what we do with most others. We ignore it. But here's the thing. We need hope. Desperately, in fact. We need a frontier unfettered by the weight of destruction, of the ugly realities we've rained down on nearly every other social, political, cultural, and environmental landscape we've touched. We need to do this right, to change systems intent on recreating the same wastelands of this particular Fertile Crescent, to invest in protections, to act globally from a local position. And we can. For once, we can. Not in reaction to atrocities, to destruction, demolition, deforestation, but before they occur, before the tipping point is reached. This is our chance. This is our chance to be the future ancestors who turn the tide.
It seems now more than ever that we have found ourselves on the cusp of monumental worldwide change. Whether we consider the environment, politics, infrastructure, health, economics, or inequities across a broad swath of social constructs, the consensus is clear and urgent. All is not as it should be. The United Nations, a consortium of 193 member states from around the globe, agrees. In 2015, the UN unanimously adopted the 17 Sustainable Development Goals, the SDGs. These goals call for urgent action in global partnership to secure peace and prosperity for people and the planet, now and into the future.
In alignment with the SDGs, Hatch, a curated network of artists, activists, and entrepreneurs working together to accelerate positive global change, has partnered with I Am Interchange to fuse adventure journalism with experiential design labs to develop innovative solutions to complex global challenges. Hey everybody, thanks for listening to the podcast. If you enjoy it, please subscribe or leave us a rating. This episode was produced by Yara Craner, Susan Karstensen, and me, Tate Chamberlain. A shout out to our media and production team, Jessica Byerly, Darko Sevilla, Jacob Desch, Sean Mackinson, Amin Yarsu, and Zane Giordano. A special thanks to Atosa Sultani and Kennedy Smith. With so much gratitude to the Hatch supporters, Steelcase, the Kauffman Foundation, the Gwydion Fund, Envision Equality, the Hatch Volunteers, Board of Directors, Hatch Guardians, and the community who help make this work and mission possible. To learn more about Hatch, visit hatchexperience.org. Building community could not happen without food. And with that, I'd like to thank Whistle Pig Korean, Red Tractor Pizza, and Zocalo Coffee House. Do you have an issue that's riddled by gridlock in your community? Shoot me an email at tate@iaminterchange.org. That's tate@iaminterchange.org. Remember, share airtime and don't ruin dinner.